Hello students, welcome to the channel of Vedant classes. So in this lecture we'll solve the exercise 2.2. Okay. So in the first question they asked us to find the zeros of polynomials. Okay. And we need to verify the relationships between zeros and the coefficient. So we have found the relationships between zeros and coefficient in the previous lecture. Okay. So till now if you haven't seen the lecture, then you can search it in the playlist of Vedant classes, that is chapter 2 of polynomials. Okay. So in lecture number 3 you will get that thing. You will get the concept of relationship between zeros and coefficients. So now let's start solving the sums. The first sum, it is given that x square minus 2x minus 8. So in this sum we just need to find the zeros. So equate this polynomial with 0. Okay, so x square minus 2x minus 8. So therefore here it is minus minus, so difference, so minus 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 plus. Okay, so difference 2 that you need, so split 8 into 2 parts whose difference is equal to 2, so that is 4 into 2, you will get 2, right? So this is how you can go through. Okay, so in the lecture number 2 you will get this concept that how to factorize, right? So x square minus 2x minus 8, so it will be x square minus 4x plus 2x minus 8, so that will be equal to 0. So therefore taking x common, this will be x minus 4. Here it will be plus 2 common, taking x minus 4. Okay, so it will be like this, x minus 4 and x plus 2 equal to 0. So therefore x minus 4 is equal to 0. So therefore x equal to 4. Or x plus 2 equal to 0. So x will be equal to minus 2. Right? So let these are our zeros, 4 and minus 2. So let alpha be equal to 4 and beta be equal to minus 2. Okay. So now let's verify the relationship. So first is sum of zeros. So that is alpha plus beta is equal to minus b by a. Okay. So let note down the values. Here a is equal to 1. Then b will be equal to minus 2. And c will be equal to minus 8. Okay, so these are the values of a, b and c. So now let's start with the LHS, that is alpha plus beta. So what is alpha? That is 4. And what is beta? That is minus 2. So this will be 4 minus 2, so it will be 2. In RHS it is given minus b by a. So this will be minus of b, so that is equal to minus 2. And a, so value of a is 1, so this will be equal to 2. So you can say LHS equal to RHS. So we have verified for the sum of zeros. Now let's see for the product of zeros. So second, for the product of zeros, so that is in that case alpha beta, that is equal to c by a. So LHS, that is equal to alpha into beta. So what is alpha? That is 4. So 4, and beta, that is equal to minus 2. So this will be equal to minus 8. Now in RHS, that is equal to c by a. So this c is equal to minus 8 and a, this is equal to 1. So this answer will be minus 8. So here also you are getting LHS equal to RHS. So it means that we verified this relationship. So this is how you can go for this sum. Okay, this is the complete solution of this sum. So now let's see the next question. So next question, second one, that is 4a square minus 4s plus 1. Okay, so this is the next polynomial in terms of s. Okay, it is given. So now let's factorize this polynomial. So to factorize it, we need to equate it with 0. So 4s square minus 4s plus 1. Okay, so what you need to do, you just need to consider both sides, right? 4 into 1, so that will be equal to 4. Now divide, here say it is minus plus, so minus minus, so minus minus plus. So divide 4 into 2 parts, so addition is equal to 4. So by equating it with 0, we'll get 4s square minus 2s minus 2s plus 1, that will be equal to 0. So therefore taking 2s common, so here it will be 2s minus 1 taking minus 1 common from here, so it will be 2s minus 1 equal to 0. So see, we are getting 2s minus 1, and here also that is 2s minus 1 equal to 0. So basically we got the 2s minus 1 the whole square. That is, okay, it is clear that this equation is perfect square equation. Okay, so by equating this 2s minus 1 with 0, we will get s equal to 1 by 2, or equating this 2s minus 1 equal to 0, you will again get s equal to 1 by 2. Okay, so let alpha equal to 1 by 2 and beta is equal to 1 by 2. So here alpha and values of alpha and beta is 1 by 2, 1 by 2. Okay, so we got the values of alpha equal to 1 by 2 and beta is equal to 1 by 2. Okay, so we are having the polynomial that is 4s square minus 4s plus 1. So here a is equal to 4, b will be equal to minus 4, and c will be equal to 1. Okay, so now let's verify the relationship. First we'll start with sum of zeros, so that is equal to alpha plus beta, that is equal to minus b by a. So let's start with LHS, that is equal to alpha plus beta. So we get 1 by 2 plus 1 by 2, so answer will be 1. And RHS, in that case, that is equal to minus b by a. Okay, so what is b? That is minus 4, so minus of minus 4 upon what is a? That is equal to 4, so this will be 4 by 4, so you get 1. So here we are getting the conclusion LHS equal to RHS. So we verified the relationship, right? Now see, in the second one, that is product of zeros, so that is alpha beta equal to c by a. So LHS equal to alpha beta. What is alpha? That is 1 by 2, and beta is also 1 by 2, so answer will be 1 by 4. Now in the RHS, that is equal to c by a. What is c? That is 1, and a is 4. So again we got the same values. Okay, here we just need to verify that we are getting the same values all the time, because we have just proved these results, right? So in this case also LHS equal to RHS. Okay, so now let's solve the next question, that is question number 3. See, in the question number 3, the question is 6x square minus 3 minus 7x. Okay, now see, it is not there in the standard form. So first of all, write it accordingly in the decreasing power. So our polynomial will be like this: 6x square, then minus 7x, and then minus 3. Okay, you just need to rearrange these terms and equate it with 0. Okay, so now see, here it is 6 and 3. Okay, so split 18 into two parts, minus minus, then minus plus, and we need to get the difference. Okay, so difference between two numbers equal to 7, so that will be 9 twos are. So here factors will be 6x square minus 9x, okay, plus 2x minus 3, that will be equal to 0. So here take 3x common, so taking 3x common, it will be 2x minus 3, okay, plus 1 common, then it will be 2x minus 3 equal to 0. So therefore this will become 2x minus 3 and 3x plus 1 equal to 0. Okay, so therefore 2x minus 3 equal to 0, or 3x plus 1 equal to 0. So therefore x will be equal to 3 by 2, or here x will be equal to minus 1 by 2, sorry, minus 1 by 3. Okay, so we are having the two values, that is 3 by 2 and minus 1 by 3. So let alpha equal to 3 by 2 and beta is equal to minus 1 by 3. Okay, see here the value of a will be, from this you need to write, not from this, okay, because it is not in a proper standard form. Okay, so here value of a is 6, the value of b is minus 7, value of c is minus 3. Okay, so first is sum of zeros. So for the sum of zeros, alpha plus beta equal to minus b by a. So let's start with LHS again, alpha plus beta. Here what is the value of alpha? That is 3 by 2. Okay, so value of alpha is 3 by 2 and beta is minus 1 by 3. Okay, so alpha is 3 by 2 and beta is minus 1 by 3. So this will be 3 3s are 9 minus 2 upon 6. So this value is equal to 7 by 6. Okay, now in the RHS it is equal to minus b by a. So this will be negative of negative 7 upon a, that is equal to 6. So this value will be equal to 7 by 6. Okay, so see again you are getting the same value. So we are having the result LHS equal to RHS. Now the second, that is product of zeros. So what is product of zeros? That is equal to alpha beta equal to c by a. So let's start with the LHS, that is alpha beta. Okay, so what is the value of alpha? That is equal to 3 by 2. And what is the value of beta? That is equal to minus 1 by 3. Cancelling this, we will get minus 1 by 2. Let's solve for the RHS. So RHS is c by a. So what is the value of c? Here value of c is minus 3 and value of a is 6. So again you are getting minus 1 by 2. Okay, so in this case also LHS will be equal to RHS. Okay, so we verified the relationship for both the case, for sum of zeros as well as product of zeros. Okay, now let's see the fourth question. The fourth question is 4u square plus 8u. Okay, so let's factorize this. So 4u square plus 8u. So 4u square plus 8u is equal to 0. Okay, so you don't need to factorize this, you just need to take common. So 4u will be common in this, so it will be u plus 2 is equal to 0. Okay, so now equating 4u is equal to 0 or u plus 2 is equal to 0. You don't need to compare the 4 as well, you can directly write u is equal to 0. Okay, because 4 cannot be equal to 0. Okay, so u equal to minus 2. So this will be the factors. So let alpha equal to 0 and beta is equal to minus 2. Okay, also note the value of a, b, c, that is here a is equal to 4, then b is equal to 8, and there is no constant term, so c will be equal to 0. So now first is sum of zeros. So sum of zeros, that is alpha plus beta equal to minus b by a. So LHS equal to alpha plus beta, so that is equal to 0 plus minus 2. So 0 minus 2 will be equal to minus 2. In RHS it is minus b by a, so that will be minus 8 upon 4. So answer will be minus 2. So here LHS will be equal to RHS. Now see in the second case, that is product of zeros. So alpha into beta, that is equal to c by a. So LHS equal to alpha beta. Okay, so take the product of both this, so it will be 0 into minus 2. So answer will be 0. Okay, in RHS it will be c by a. So what is the value of c? Here the c is 0. So this will be 0 by 4. So again answer will be 0. So in both cases we are getting 0. So LHS will be equal to RHS. Okay, so this is how we verified the relationships. Now let's solve the fifth question. So fifth question is t square minus 15. T square minus 15. Okay, so let's solve this question. So t square minus 15 is equal to 0. So it will be t minus root 15 and t plus root 15. Okay, is equal to 0. So therefore you can compare t minus root 15 equal to 0 or t plus root 15 equal to 0. So therefore t will be equal to root 15 or t will be equal to minus of root 15. Okay, so let alpha is equal to root 15 and beta is equal to minus root 15. Okay, let's note the value of a. what is the value of a? That is coefficient of t square, so it will be equal to 1. Here there is no term involving t, okay, so coefficient of such term will be 0. Here we are having the constant term, that is minus 15, okay, the value of constant term is minus 15. So let's start with sum of zeros. What is sum of zeros? That is alpha plus beta equal to minus b by a. So LHS will be equal to alpha plus beta, so that will be equal to root 15 minus root 15, so answer will turn out to be 0. In RHS, the minus b by a, so what is b? That is 0, 0 upon 1, so answer will be again 0. So here we verified the relation of sum of zeros, that is LHS equal to RHS. Now let's see for the product of zeros. Okay, so for the product of zeros, alpha beta will be equal to c by a, so LHS will be equal to alpha into beta. So see, it will be root 15 into minus root 15, so answer will turn out to be minus 15. In RHS, this will be equal to c by a. What is the value of c? That is minus 15, and a is 1, so answer will be minus 15. So again we got LHS equal to RHS. Okay, so we verified the relationships for this. Okay, so now let's solve the sixth question, that is last for the question number 1. So in that, the polynomial given is 3x square minus x minus 4. Okay, so we need to factorize this by splitting off middle term. So let's start factorizing this, equating it with 0. 3x square minus x minus 4, that will be equal to 0. Now 4 3s are 12, so you need to find the difference 1. Okay, here you need to find the difference 1, so that is obvious. 4 3s are, so that will be 3x square minus 4x plus 3x minus 4 equal to 0. So taking x common from this, it will be 3x minus 4. Taking 1 common, it will be 3x minus 4 equal to 0. So therefore 3x minus 4 and x plus 1, okay, equal to 0. So therefore 3x minus 4 equal to 0, or x plus 1 will be equal to 0. So therefore the value of x is 4 by 3, okay, or the value of x, that will be equal to minus 1. We got the values of x as 4 by 3 and x equal to minus 1. Okay, so now let alpha equal to 4 by 3 and beta is equal to minus 1. Okay, also note the values of a, b and c. So here the value of a will be equal to 3, b will be equal to minus 1, and c will be equal to minus 4. Okay, the polynomial was 3x square minus x minus 4. Okay, we are having that polynomial. So a will be equal to 3, b will be minus 1, and c will be minus 4. Okay, so let's start with the first, that is sum of zeros. So that is alpha plus beta equal to minus b by a. So LHS equal to alpha plus beta. Okay, so that will be equal to 4 by 3 minus 1. So answer will be 4 minus 3 by 3, so that will be 1 by 3. Here RHS, that is equal to minus b by a. So minus of minus 1 upon 3. So this is equal to 1 by 3. So therefore we are having LHS equal to RHS. Now for the second, product of zeros. So alpha into beta, that is equal to c by a. So LHS will be equal to alpha beta. Okay, so what is alpha beta? That is 4 by 3 into minus 1. So answer will be minus 4 by 3. And RHS equal to c by a. So value of c is minus 4, a is 3. So again we are getting the same value. So that is equal to LHS equal to RHS. Okay, so this is all about question 1. Now let's start with the question number 2. Okay, so in the question number 2, they asked us to find the quadratic polynomial. Okay, we need to generate a quadratic polynomial from given number as sum and product of zeros respectively. So numbers that is given in the question are sum and products respectively, and from that we need to generate the quadratic polynomial. Okay, so let's see how to deal with this question. So see, in the first question it is given 1/4 and -1. Okay, so now let's start with the method. Now see, in this question, first of all note that sum of zeros, that is equal to 1/4. Now what is sum of zeros? Sum of zeros is minus b by a, so this will be equal to minus b by a. This will be equal to 1/4. Now just interchange this a and 1. So that minus b upon 1, that will be equal to a by 4. And this ratio, consider that ratio that is equal to any constant, that is k. Okay, here k is not equal to 0. Okay, that this k we used in the derivations. Okay, so therefore minus b by 1 equal to k, and you can compare a by 4 equal to k. So b will be equal to negative k and a will be equal to 4k, right? So you got the values of a and b. Now what you need to do, you need to write the product of zeros. So product of zeros, that is equal to -1, it is given. So therefore c by a, product of zeros is c by a, that is equal to -1. Okay, so therefore you can say c will be equal to negative k, c will be equal to minus a. Now we are having the value of a, that is equal to 4k. So therefore c is equal to minus 4k. Okay, now general equation of quadratic polynomial. What is general equation of quadratic polynomial? Is p of x is equal to ax square plus px plus c. Okay, so just substitute all the values and you will get the polynomial. So this will be equal to 4k x square. Here b is equal to minus kx. Okay, and c will be equal to minus 4k. So taking k as common, this will be equal to 4x square minus x minus 4. Okay, where k is not equal to 0. Okay, that's what we have written. So this is the simple technique to generate a polynomial. Is it clear? You can also use one shortcut method. Okay, using the general equation that we have written it in the notes. What is the short method for this? Now see, you are having the equation p of x equal to k in bracket x square minus sx plus p. Here s is sum and p is product. So you just need to substitute the values over there. Okay, so this will be k x square. What is the sum? That is 1/4. So you can write 1/4x. And what is the product? That is -1. So you just need to write -1. Okay, so now taking 4 as common, so k by 4, this will be 4x square minus x minus 4, and this k by 4 will generate a new constant because k is also a constant. So you can write k dash 4x square minus x minus 4. So this is how you can generate a polynomial. So this is a short trick that you can find the polynomial using this general form. Okay, so if it is asked in 2 or 3 marks, then you should go for the long technique, and if it is asked in a short question, 1 mark question, then you should apply the short method. Okay, so now let's see the next questions. Okay, now let's see the question number 2, that is √2 comma 1/3. Okay, so let's solve this one. You can go for the same practice. Okay, here sum of zeros, that is equal to √2. So therefore you can write minus b by a is equal to √2 by 1. So therefore minus b by √2 is equal to a by 1 equal to k, where k is not equal to 0. Okay, so therefore minus b by root 2 is equal to k. Okay, and you can consider a by 1 is equal to k. So therefore b will be equal to minus root 2k and a will be equal to only k. Now consider the product of zeros. So that will be equal to, what is the product of zeros? That will be equal to 1 by 3 is given. Then c by a is equal to 1 by 3. Okay, so therefore c is equal to a by 3. What is a? That is equal to k. So value of c is k by 3. Okay, so now let's write the general equation. So general equation of quadratic polynomial is p of x is equal to, you can write ax square plus bx plus c, where a is not equal to 0 and a, b, c belongs to real numbers. Okay, so just substitute all the values. So p of x equal to, what is the value of a? That is kx square. So this will be kx square. Then what is the value of b? Minus root 2 kx. So minus root 2 kx. What is the value of c? That is k by 3. This will be plus k by 3. So therefore p of x, taking k as a common as a LCM, so this will become k by 3. This will be 3x square minus 3 root 2x plus 1. Okay, so this is the final polynomial, 3x square minus 3 root 2x plus 1. Okay, so you consider this k by 3 as another new constant k dash, 3x square minus 3 root 2x plus 1, where k dash is not equal to 0. Okay, so this is the final answer. Now using the short method, let's see how to deal with it. So p of x is equal to k in bracket x square minus sx plus p. Okay, where k is not equal to 0. So k, this will be x square. What is s? That is root 2. So this will be minus root 2x. What is p? That is 1 by 3. So plus 1 by 3. Okay, so again you just need to carry forward the same steps. So this will be k by 3. This will be 3x square minus 3 root 2x plus 1. Considering k by 3 as a new constant k dash, so you get the same answer, 3 root 2x plus 1, right? Again, where k dash is not equal to 0. Okay, so is it clear? So now let's solve the next question. So let's start with the third question. So in third question, the values given is 0 and root 5. So now let's see how to solve this one. 0 and root 5. So sum of zeros. Sum of zeros is given as 0. So minus b by a, we can write it as 0 upon 1. So this will be minus b by 0 is equal to a by 1. Let's say it is equal to k. See, anything like this not possible. We cannot write 0 in the denominator. But here we are comparing the ratios, okay, to find the value of b. So you can write it like this, minus b by 0 is equal to k. So b will turn out to be 0 actually. Then a by 1 is equal to k. So value of a will turn out to be k. So we got the values of b as 0 and a is equal to k. Now say here, product of zeros, that is equal to given as root 5. So therefore you can write c by a is equal to root 5. So what is the value of c? That is equal to a root 5. So value of a is equal to k. So we are having the value of c is equal to k root 5. So now we are having the value of a as k, b is 0 and c as k root 5. Okay. So general equation of quadratic polynomial. General equation of quadratic polynomial is given as p of x is equal to ax square plus bx plus c. Okay, where a is not equal to 0 and a, b, c belongs to real numbers. Okay, So just substitute all the values. P of x equal to, what is the value of a that we got as k? So this is kx square. The value of b is 0, so this will turn out to be 0, and the c, that is equal to k root 5. Okay, so taking k as a common, we'll get x square plus root 5, where k is not equal to 0. So this is our required polynomial. Okay, now let's see the short method. That is p of x is equal to, what is p of x? That is k x square minus sx plus p. So see, here sum is given as 0, so this will be k x square. Here k is not equal to 0, it will turn out to be 0, and the product is given as root 5, so this will be plus root 5. Okay, so final answer, p of x equal to k, then x square plus root 5. Okay, where k is not equal to 0. Okay, now let's solve the next question. The next question is 1, 1. Okay, very easy. So fourth is given as 1, 1. Okay, so it is quite easy to solve. So let's start again. Here sum of zeros, that is given as 1, so therefore minus b by a is equal to 1, so therefore minus b by 1 is equal to 1 upon a by 1, sorry. Okay, here we let it as any constant, k is equal to 0. Okay, so here you can write 1 by 1. Okay, so therefore minus b by 1 is equal to k, or a by 1 is equal to k. So you will get the value of b as minus k. Okay, and a is equal to plus k. Okay, now product of zeros, that is equal to 1, so therefore c by a is equal to 1. So what is the value of c? That is equal to a, so c will also be equal to k. So you are having the values. Now let's write the general equation of quadratic polynomial. So p of x is equal to ax square plus bx plus c. Okay, where a cannot be equal to 0, a is not equal to 0, and a, b, c, all three belongs to real numbers. Okay, so substitute all the values, simple. That is kx square minus kx plus k. Taking k as common, it will be x square minus x plus 1, where k is not equal to 0. So this is your final answer. Okay, so x square minus x plus 1 is a required polynomial. Let's solve it using the short method. So p of x, that is equal to k x square minus sx plus p, where k is not equal to 0. So just substitute the values as 1, 1 here. So it will be x square minus x plus 1. Okay, very easy. So okay, now let's see the fifth question. In fifth question it is given minus 1 by 4 and 1 by 4. Okay, so let's start solving this. So let's start with sum of zeros, that is given as minus b by a. Okay, or here it is given minus 1 by 4. So therefore minus b by a is equal to minus 1 by 4. So you can write minus b upon minus 1 is equal to a by 4 is equal to k. So therefore minus b by minus 1 is equal to k, and a by 4 is equal to k. So therefore you will get the value of b as only k, simple, and value of a is 4k, right? Now product of zeros. So what is product of zeros? That is equal to 1 by 4. So therefore c by a is equal to 1 by 4. So therefore value of c is equal to a by 4, and a by 4, that is 4k by 4, the value of c will be equal to only k. Having all the three values now. So general equation of quadratic polynomial will be p of x is equal to ax square plus bx plus c where a is not equal to 0 and a, b, c all belongs to real numbers. Okay, so now just substitute all the values of a, b, c. So p of x will be equal to, here it will be 4kx square, here it will be plus kx, here it will be plus k only. Okay, so taking k common, okay, so therefore p of x will be equal to, okay, here, so here k will not be equal to 0. Okay, so taking k as a common, here you will get 4x square plus x plus 1. Okay, so this is your final answer where k is not equal to 0. So now let's see it by shortcut method. Okay, so p of x is equal to k in bracket x square minus sx plus p, where k is not equal to 0. So what is sum? The sum is minus 1 by 4. So this will be k x square. Now see, this minus and minus will become plus 1 by 4 k plus 1 by 4. Okay, so taking this as LCM 4, so this will be 4x square plus x plus 1. So this is new constant k dash 4x square plus x plus 1. So this will be your final answer. Okay, where you can write k dash is not equal to 0. Okay, is it clear? So now let's solve the final question, that is 4 and 1. So in 6th, this is given 4 and 1. Okay, so let's see this one. Sum of zeros, that is equal to 4. So therefore minus b by a is equal to 4 upon 1. So minus b by 4, that is equal to a by 1 is equal to k, where k is not equal to 0. So you can compare minus b by 4 is equal to k and a by 1 is equal to k, right? Okay, so you will get the value of b as 4. So therefore b will be equal to minus 4, this is 4. So b will be equal to minus 4k and a will be equal to only k. Now product of zeros, that is equal to 1. So therefore c by a is equal to 1. So c is equal to a and that will be equal to k directly, right? Value of c is k. So now general equation of quadratic polynomial, that is equal to p of x is equal to ax square plus bx plus c, where a is not equal to 0 and a, b, c, thus all three belongs to real numbers. Now substitute all the values, simple, that is kx square minus 4kx then plus k. Taking k common, then it will be x square minus 4x plus 1. Okay, where k is not equal to 0. So this will be your final answer. Let's solve it using the short method. So p of x is equal to k in bracket x square minus sx plus p, where k is not equal to 0. So k, what is s? That is 4. So this will be x square minus 4x, and product is 1. So this will be 1. So this will be your final answer. P of x, that is equal to k is not equal to 0. Okay, so that's it. That's all about the exercise 2.2. Okay, so that's it from this lecture. Please like, subscribe and share the channel if you are really finding it helpful, enjoying learning the mathematics here. Okay, so thanks a lot.